Hi friends, today we are going to discover the question of what's the Chinese remainder theorem on Chinese. And first, let me introduce to you a little bit history of the Chinese remainder system. So this system is also called Sunzi Dingli, which in Chinese, and if you call that in English, will be Sunzi theorem. And this theorem has the earliest linear congruent equation with one variable in Chinese history, and it was discovered by Sun Zi in 3rd century. And you can see Sun Zi is a really famous Chinese general, military strategist, writer, philosopher, and mathematician who lives in Eastern Zhou period of ancient China. And so this theorem was discovered in his book, which is called Sun Zi Suan Jing. And in English, it's called Mathematical Classics of Sun Zi. And there are three. This book is a really famous book because it is one of the most influential mathematical works in Chinese history, and there are 3 chapters in this book, and it's about like measurement, Bayesian system, fraction, area, population, and volume. And this book is also include one really famous problems named the chicken and rabbits in 1 cage problem. And I can read the problem to you. So the problem is, in a cage, chickens and rabbits add up to 35 heads and 94 feet. And please count the number of chicken and rabbits. So in this question, we're going to use like linear equation and 2 variables to find the answer. So this is a really famous question, but today we're going to focusing on the Chinese remainder system. Here is a picture of the Chinese remainder system in the book of Sun Zi Suan Jing, since which we do not know the number. If we count them by 3, the remainder is 2. If we count them by 5, the remainder is 3. If we count them by 7, the remainder is 2. So how many things are there? And Sun Zi answered 23. So in later of the presentation, I'm going to tell you how did Sun Zi find out and why this works in the whole system. Okay, now let's take a look at the timeline. So later in history, Han Xin, who is a really famous general in Han Dynasty, used Sun Zi's method to count his army. And Qin Jiushao and Yang Hui from Song Dynasty also read more explanation of this method. And actually, Qin Jiushao read this method in the 9th chapter of the Mathematical Arts, which is a really famous book, and we talk about this in our class too. Okay, now I think we are ready to do some math. So according to the Chinese legend, there was one time Han Xin wanted to count his soldiers in his army, so he let the soldiers stand in a row by group of 3, and there was 2 people left, so he got a remainder of 2. And if he asked the people to stand in groups of 5 and 3 people left, and we got a remainder of 3. And if the people stand in groups of 7 and 2 people left, and he was asking how many people is in my army. So now I think we are ready for some math. And according to the Chinese legend, there was one time Han Xin wanted to count his soldiers in his army. So he let the soldiers stand in groups of 3, and he got a remainder of 2. Then he let the soldiers stand in groups of 5, and he got a remainder of 3. And he asked the soldiers to stand in groups of 7, and he got a remainder of 2. So now he was wondering how many people is in his army according to the prior information. Now let's use Sun's method to solve this problem. Fun fact, there was a mathematician from Ming Dynasty whose name is Cheng Dawei, made a poem for this method. So here is a poem. So we suppose there are n soldiers in the army, so n soldiers. And suppose A is a remainder of n divided by 3, and B is a remainder of n divided by 5, and C is a remainder of n divided by 7. So we can write like this. So n is congruent to A mod 3, and n is congruent to B mod 5, and n is congruent to 2 mod 7. And from our prior information, we know n is equal to 2, A is equal to 2, B is equal to 3, and C is equal to 2. And so let's go back to our poem to help us to solve the question. So in the first sentence, we have 3 subtangents in the family. So the word subtangents means people in the age of 70. So then we use 70 times A. And we're going to plus 21 branches of plum tree from 5 trees. So we're going to add 21 times B. And we're going to plus, so middle of the month in China, we have a festival called the Moon Festival, which is the 15th day of the month of August. So that will be 15 plus C. And in the last sentence, we're going to subtract 105, and we can get the answer. So if 105 x, and we can get the answer. So we know A, B, and C, so we can write the math sentence as 70 times 2 plus 21 times 3 plus 15 times 2 minus 105 times 2. So which we're going to have 223 minus 105. 5 times 2, and will be equals to 23. So now we find out our answer. So the least amount of soldiers in the army will be 23. And we can check our answer, like 23 divided by 3 equals to 7, which is and we have a remainder of 2. And 23 divided by 5 equals 4, and the remainder is 3, and 23 divided by 7 is 3, and the remainder is 2. So, and we can see there's something interesting with the numbers 70, 20, and 15 here. So we can see 70 is divisible by 5 and 7, and 21 is divisible by 3 and 5, and 15 is divisible by 3 and 5. So we want to make sure everything here, the remainder is 1, and we minus 105. And how we get this number? This is the least common multiple of 3, 5, and 7. Furthermore, Qin Jiushao discovered we can technically solve every pair of congruence have relative prime. This means if we read our method in algebraic symbols, which we're going to do something like this. We're going to write this as this: a1, a2, a3, and m1, m2, and m3. I'm just going to erase this part, and everything over here. So m, all the m's have to be relatively prime. Now let's go back to our question of what's the Chinese remainder theorem Chinese. For me, I think the Chinese remainder theorem is Chinese because it was the earliest human record on the remainder theorem, which is in 3rd century. And however, I have to admit that it was not that popular. Like, we did not share this with other cultures during 3rd century in Sun's time. So it was getting spread out after Song Dynasty, which the Western culture already had some ideas about the remainder system. But now we can see a bigger pictures of the remainder system by combining the thoughts on the Eastern and Western studies.